This episode is sponsored by Audible. Carl Sagan famously said the universe and cosmos is all that is, or ever was, or ever will be, but what if it's just the tip of the iceberg? When we look at the night sky, we can see several thousand stars. As we reach the modern era, we learn there were millions of times more stars in our galaxy, itself one of trillions we can see. Our universe was not a few thousand stars, but billions and billions of them. But this is probably not the sum of the universe, which expands outward in all directions equally until we see a wall of ancient light, the cosmic microwave background radiation, left over from when the universe was rather young and hot, and redshifted from its journey through nearly 14 billion years. This we call the observable universe, and we suspect it goes beyond that, probably far beyond that, and possibly even infinitely so. And yet, that's just this universe, in this iteration and timeline. We don't know if anything preceded this universe, or if our Big Bang was merely a relatively local affair in some other, older, larger universe, or if every possible timeline of our universe has happened, or both. We don't know if other places with other rules might exist, extra dimensions or different physical constants. We're going to be exploring these concepts today, and one of the first problems we have is simply naming them. The word universe derives from the Latin universum, which variously means all together, all in one, whole, entire, and relating to all. It's meant to be the whole world and cosmos, the totality of existing things, and this usage long predates our even knowing what galaxies were. When we started realizing that other options might be on the table besides this region of space originating from the Big Bang, we probably should have come up with another word for it and kept universe more broad. But instead we got terms like parallel universes, multiverse, alternate realities, higher dimensions, the ultimate ensemble, and even the grand shebang, a personal favorite. Let me just add that none of this is anything more than theory at the moment. There is not a drop of evidence to support anything beyond our observable universe at this time, an arguable exception being the idea that the universe continues on beyond the observable universe, since we can see space expanding inside the observable universe, and we wouldn't expect we were at the exact center of the universe here on Earth, and that the edge is just a fairly uniform blob of photons as we'd expect for something that used to be hotter and denser, but has been expanding. So the most obvious conclusion is that the universe keeps on going beyond the observable universe for at least a considerable way, as if Earth is randomly located in that universe, it would need to be decently bigger than the part we can observe for us to be able to see equally in all directions. If you are standing in a random spot in a dark empty warehouse with a lantern, but there's no wall visible in your circle of light, that warehouse is probably far larger than the area you can see. Same concept. We can logically say then that the universe probably extends a good distance farther than what we can see, but whether that's just a little bit bigger or outright infinite, we can't prove at this time and probably could only prove with some new physics. That's even more the case with all these other places, multiverses, higher dimensions, alternate timelines, and so on. We can see a mathematical basis for their existence, but that doesn't mean they do exist, or that all the variations we might imagine do if some do. And we have no way at this time of testing them and quite possibly never will. Indeed, one might argue that if we can't ever see or reach these places, even if they do exist, they might as well not exist, and that would even be true of the area outside of our observable universe. Indeed, we believe large sections of the observable universe have already left the volume we could ever send a signal to, let alone a ship, and we are just seeing their ghostly afterimage as they fell over that cosmological event horizon, our lantern as it were, and more galaxies will as time goes on. We use the term Hubble volume as this region of space we could actually send a signal to or receive one from if they send it today, rather than the entirety of the observable universe, which would include those regions we can only see the ghosts of. If anyone lives in those spots, they presumably have their own observable universe and Hubble volume centered on them. It is entirely possible that even 100 trillion years from now, as our last natural stars burn out, that we still won't know if there is actually anything beyond this universe, since unless you can actually look at or visit such places, you can't really be sure they exist, and we have no avenue for doing either under known science. However, we have some fairly compelling arguments as a result of this or that cosmological theory, regardless of evidence to back them, so I don't want to imply they just got made up at some point. Rather, they would appear likely consequences of known or hypothetical physics. You have to be careful with stuff like that, and can't just assume they exist as a result, but again, they are more solid than just daydreams of science fiction authors. On the theoretical side, we can speculate though, and there has been quite a few classification systems that have emerged, and we'll discuss a couple today. Cosmologist Max Tegmark proposes 4 possible levels of multiverse. The first is the extension of our own universe, out beyond the observable, and specifically the case that is infinite, or effectively so, rather than just significantly larger than what we can see. Incidentally, when I say effectively infinite, this is because in a truly infinite system, things will repeat. And since you'd always have a maximum volume of space you could look at and compare, the Hubble volume, as huge as such a place is, it is finite and has a huge but also finite number of configurations all the various atoms could be in. So you'd expect in an infinite system to come across repeats, and you couldn't tell those identical places apart, and it arguably doesn't matter. If everything is literally exactly the same, it's maybe no more different a place than a circular timeline is a new era. That's arguably a semantic point, but we can calculate the average distance you'd have to travel in such an infinite system to reach a repeat Hubble volume, and it's about 10 to the 10 to the 115 meters away. That's the distance that's the effective edge of infinity, because even if we kept going, you're not finding anything new or unique. A quick note on exponents of exponents, since those come up a lot in discussion of multiverses and can be confusing in scale. When you see 10 to the 10, it means 1 followed by 10 zeros, or 10 billion, but 10 to the 10 to the 10 would be 1 followed by 10 to the 10 zeros, or 10 billion zeros, enough to fill a library if we wrote them down on paper. When we start talking about numbers like 10 to the 10 to the 115, or how many permutations of a universe might exist in the multiverse, we have to use that notation because if we wrote the number out on paper, it would be so big and long it would undergo gravitational collapse into a black hole. Level 2 is one in which we have universes with different physical constants, like if gravity or the Hubble constant for expansion were a bit different. This is the consequence of the eternal inflation theory, a variation of cosmic inflation theory which Alan Guth came up with back in 1979 to explain some problems with matter distribution in the normal Big Bang model, or why the universe could be flat and homogeneously distributed. Cosmic inflation theory often gets misunderstood as referring to the normal cosmic expansion we always talk about with galaxies getting further away, but actually refers to a very brief moment of time, the barest instant after the Big Bang. You'll hear it said that the universe expanded by a factor of 100 trillion in this brief instant, lasting only about a billionth of a trillionth of a second. And I always feel obliged to point out that that post-inflation size was probably only about a meter across or less. Not to say that the pre-inflation size was insignificant, in such a short time the universe expanded by a factor greater than all expansion since. That's only our observable portion incidentally, the rest of the universe might have been a good deal bigger or even infinite, we only know about that chunk. Prior to that it was subatomic, so inflation was just a rapid brief burst. We have no evidence of this, we can't see further back in time prior to the event of last scattering when the universe was about 300,000 years old, and inflation is thought to have happened in the first picosecond. So why do we think it happened? Well, because the universe is not homogeneous, it has a large-scale structure and we can't see how that could have happened without such a fast expansion and accompanying quantum fluctuations causing variations. It's essentially the theory for why the universe isn't evenly spread at the galactic supercluster scale, so we hypothesize a quick burst of inflation back when the observable universe was smaller than an atomic nuclei that jumped it to the handheld size. Very tiny and random distributions in that subatomic thing could then have expanded to bigger gaps rather than an even spread of matter and energy. Now that's regular cosmic inflation theory, but as mentioned we have another called eternal inflation. A problem with regular inflation is why it should actually stop after an instant, exiting this rapid expansion phase, something others have sought to address called the graceful exit problem, and a topic for another time. Eternal inflation says it didn't stop, or didn't stop everywhere, that some places stop stretching to form distinct bubbles, like our universe, and that you could get a lot of mini-universes popping up. There's quite a few variations of this general notion, but level 2 encompasses this and other things like the option that each black hole might spawn a new universe, though its mass and specific physical constants might vary. A new one might be a bit less massive than ours, or have its electromagnetic or gravitational force be a bit higher or lower, or so on. Again, no evidence for such a theory, or theories as it includes more than one, that would result in similar extra universes, but they do come about as a reasonable consequence of another theory. Level 3 is a consequence of the mini-worlds interpretation of quantum mechanics. There are a bunch of interpretations of quantum and Schrödinger's cat. For instance, in the Copenhagen interpretation, the cat can be simultaneously alive and dead, and you just don't know which till you observe it. Mini-worlds says it is two separate universes, one where the cat is alive in the box and another where it is dead, and you just don't know which you're in until you observe it. They are contradictory, it's not both, it's one or the other, or neither. There are quite a few other lesser known interpretations. But there's no multiverse in Copenhagen, at least of this type, where you have separate universes for each possible timeline. That's the result of the mini-worlds interpretation. Mini-worlds holds that every possible scenario for events to have played out has done so in some parallel universe, as opposed to Copenhagen, which says all can happen, but only one did once we observe it. Mini-worlds has some very bizarre implications that tend to get overlooked in fictional treatments in sci-fi, where it tends to just be a what if X event in history happened differently, and we explored those in our Infinite Improbability Issues episode, though I think most of the audience remembers that as the Quantum Cheeseburger episode. This is probably the most well-known parallel reality case, again from its popularity in science fiction, and as a quick aside, it is rather overlapping with Level 1 conceptually. As you might recall, in Level 1 I mentioned how it was infinite, or effectively so, as bits would repeat in an infinite one. This is basically the same concept and scale for mini-worlds too. Every possible configuration of the observable universe has to exist in both Level 1 and Level 3. I should note that the levels don't actually require the other levels to exist. Incidentally, multiple futures, branching off from a single moment, an event, or decision, is not the entirety of this notion. You can also have multiple paths whose sequence of events led to the same outcome. This also doesn't necessarily imply new universes are being spawned each time an event happens. Alternatively, you can just have a vast number of multiverses in which every configuration of matter and energy existed, and your timeline was essentially the path you navigated through them. Level 4, the last in Tegmark's classification system, the Ultimate Ensemble, which is essentially the one for every possible universe we can mathematically envision, and does encompass levels 1, 2, and 3. It's got no specifics beyond basically everything we can think of and describe mathematically, so is basically the miscellaneous and all of the above level. It is technically limited to only stuff we could mathematically represent, but beyond that is basically whatever you can dream up, and would include examples like a two-dimensional universe, like George Gamow Flatland, or those with a fourth physical dimension or a second temporal one, or ones that are circular, or all sorts of other dimensions having nothing to do with time and space, and not just like in string theory, where we suggest extra dimensions that are just very small. Speaking of string theory, string theorist Brian Greene discusses 9 types of multiverse. The first is the quilted multiverse, and is very similar to Tegmark's Level 1. In an infinitely large universe in which vision and travel is limited by the speed of light, you effectively have a ton of smaller observable universes or Hubble volumes in which every possible scenario has occurred, the patches on our quilt. He also gives us Type 2, the inflationary multiverse, which is very like the Level 2 of Tegmark's and the eternal inflation theory we discussed. Then we get Type 3, the brane multiverse. That's brain, B-R-A-N-E, like membrane, not B-R-A-I-N, the thing on top of your shoulders, probably getting a headache from trying to absorb all this information at the moment. Branes is an aspect of string theory in which universes like ours are essentially membranes floating around in a higher dimension, often called the bulk, and occasionally colliding or interacting with each other and setting off big bangs. They are thought to be gravitationally attracted to each other, and this is suggested for why gravity is so weak compared to the other 3 fundamental physical forces, electromagnetism and the strong and weak nuclear forces. which are fairly equal in strength to each other, but trillions of times stronger than gravity. The notion being that gravity is weak because it isn't confined to one single brane or universe, but is spread over them all and thus more diluted, though some versions of brane theory offer other unknown forces as the cause. This potentially results in them pulling toward each other and colliding occasionally with explosive results. This is thought to tend to happen every few trillion years or so to a given brane or universe, and arguably results in a cyclic process, which is Guern's Type 4 cyclic multiverses. Branes collide and create the universes. They eventually bounce back in time and collide and rinse and repeat. This is one of many cyclic models, so we keep it distinct as cyclic multiverses, as opposed to things like the Big Crunch, where a universe bangs, expands, stops, contracts back down to a dot, and big bangs again. Incidentally, you will often hear of M theory in regard to branes rather than string theory. Similar area, but for those wondering, the M usually is treated as short for membrane in terms of the branes, but Edward Witten, who came up with the notion, has said the M could also stand for mystery or magic too. Guern's Type 5 is Landscape Multiverse, and would also parallel our Tegmark Level 2. It develops the notion that quantum fluctuations in all these expanding extra universes often drop them to their lowest energy levels, creating pockets of space with sets of laws different than surrounding space. It's oversimplifying a bit, but the big oval universe is constantly expanding and regions of it coalesce into distinct universes with distinct rules, while others pop out of existence, in keeping with false vacuum catastrophe concepts. Type 6 is the Quantum Multiverse and is the Mini-Worlds Multiverse version we already discussed. Type 7 is the Holographic Multiverse and comes from the holographic principle that a surface area of space, like the surface of a black hole, has encoded on it the contents of its volume, and mostly is about thermodynamics and entropy, but also delves into the nature of our three-dimensional reality, though folks often confuse this with simulated universes, which is Type 8, a simulated multiverse in which every possible universe you can simulate is being done so by some computer or equivalent at a higher level of reality. If you recall Tegmark's Level 4, for containing any universe we can mathematically describe, this would be one way to produce them. If I can mathematically model a place, I can simulate it with a big enough computer. Type 9 is fairly similar, the Ultimate Multiverse, and like Tegmark's Ultimate Ensemble, is every mathematically possible universe. I always feel it appropriate to add an extra type or layer for all the other ones we couldn't mathematically describe, or describe in any fashion, but that's just from a habit of wanting to include all the stuff we couldn't imagine, not just the stuff we can imagine but can't actually see. This again is part of the problem with multiverses of any type. If you can't see them, detect them, visit them, make them, or somehow interact with them, it's not just that I tend to feel that they may as well not exist, but should by Occam's razor simply be assumed not to exist. Again though, these aren't being pulled out of thin air, but derived from possibilities of the various physical theories we've developed, though not proven either, but shouldn't be regarded as just random contemplation. That said, I don't like the habit of folks acting as though this is hard science, or that if one is true then they all are, when it's more like some might be, or they might all be wrong. The game changes if we can find a way to detect them. For instance, faster than light travel, at least those types that let you get to new places faster than light, as opposed to setting up a wormhole network between places you originally traveled to slower than light, would let us find out if the universe was bigger than the observable universe, though it would be impossible to prove it was infinite in size. You can't ever prove something is actually infinite, since it would take infinitely long to check, but you could check if the Level 1 or Quilted Multiverse, the infinite or effectively infinite universe, was right, or at least satisfy yourself that it was as close to infinite as you cared to check. Similarly, as we discussed in our Wormholes episode, those aren't necessarily limited to in-universe travel. Indeed, it's quite likely if they existed or can be created, they specifically only can go between universes, not inside the same universe. And the Mini-Worlds example, as I mentioned earlier, we explored in detail in the Infinite Improbability Issues episode. For things like this simulated universe or multiverse, you could find out, but only if the simulator lets you, Essentially, the programmers or creators or God, take your pick as it amounts to the same thing in this context, either leaves you proof, intentionally or accidentally, or informs you at some point. Another big aspect of this is that those hypothetical multiverses with different physical laws might often be effectively dead, even ignoring the ones that might cease to exist from a collapse of the false vacuum. Indeed, it's quite possible that most would be lifeless, and possibly that finding one capable of evolving life might be rarer than winning the lotto, or even winning it every week in a row for several months when you only bought one ticket each week. We explored that more in our Anthropic Principle and Boltzmann Brain episodes. If you can move to, or exist in them, or create them, whether it's a one-way trip or not, they'd be a very tempting option for migration, and that is a popular notion in science fiction that we explored more in our episode Aloof Aliens, but that's where we'll finish up for today. We don't know which, if any, of these notions for parallel universes and alternate realities is true, or if it really matters if we can't in some way interact with them, but if we can, it means the universe, or the sum total of reality at least, is far, far, far grander than even the vast and ancient cosmos we've come to discover this last century. An infinity of places, with an infinity of people and events, and possibly even those beyond our imagining. So we were mentioning today alternate universes that might have totally different rules, potentially anything we can imagine, which fits the notion of science fiction and space opera in particular, and many of which involve travel to alternate universes with different rules on top of seeming to operate under different scientific rules themselves. As a lot of folks have had some extra time on their hands of late, I've been getting asked for reading and watching suggestions, and I've been recommending a lot of the space opera expanded universes, since they often feature dozens or even hundreds of books and decades of setting development to create very rich universes you can delve into. I'm also of the opinion that a lot of the authors for these shared settings tend to get overlooked and underrated, and one of my personal favorites is Dan Abnett, who is best known for his work in the Warhammer 40,000 setting, often just known as 40K. 40K's novels, published by the Black Library, span hundreds of novels, set amongst possibly the most dystopian and outright crazy fictional setting I know of, yet often have surprising realism to them too. As I've mentioned before, I don't know any sci-fi setting that really manages to convey the sheer immensity of a giant and ancient galactic empire better than 40K does. There are many other great writers for the setting. Some honorable mentions go to Chris Raitt, Aaron Dembski-Bowden, John French, and Graham McNeil. But Dan Abnett is my favorite, and his Eisenhorn series, which was recently turned into a video game and is being developed into a TV show, is usually considered one of the best introductions to the 40K setting. The Black Library does a great job with their audiobook adaptations, and if you're looking for a fun setting to escape to for endless hours, you can find all their audiobooks over at Audible. Audible has an amazing catalog of audiobooks, and Audible members can choose 3 titles every month, 1 audiobook and 2 exclusive Audible originals you can't hear anywhere else, including access to news, original audio shows, and guided fitness programs. And since you can listen to your audiobooks anywhere on any device, and seamlessly pick up from where you left off, they're great for commuting, running errands, or going to the gym. You can start listening today with a 30-day Audible trial. Choose 1 audiobook and 2 Audible originals absolutely free. Just visit the link in the episode description, audible.com/Isaac, or text Isaac to 500-500. Speaking of science fiction, there was a big tendency in a lot of sci-fi to discuss the concept of antimatter as being from alternate, opposite universes. Antimatter tends to carry a lot of misconceptions, and next week we'll dig into those, explain what it really is besides explosive, how we might manufacture and store it, and some of its other uses besides blowing stuff up in antimatter factories and uses. The week after that we'll return to the Alien Civilization series to consider the idea of genuinely benevolent aliens, then close the month of May out with our monthly livestream Q&A, Sunday afternoon, May 31st, which will also be our first livestream in the new SFIA studio. For alerts when those and other episodes come out, make sure to subscribe to the channel. And if you'd like to support future episodes, you can donate to us at Patreon or our website, isaacarthur.net, linked in the episode description. Until then, thanks for watching, and have a great week.